Ask My Instructor 2.3.78. Suppose a spaceship of length L naught is traveling at a high rate of speed v relative to an observer. To the observer, the ship appears to have a smaller length given by this formula. So L on the left-hand side is the observed length. L naught is the actual length. Now, a lot of students are uncomfortable with this problem, and I think that the reason is that there's so many letters. So what you may want to do is L naught, you might want to think of that as just 100. 100 whatever. Meters is obviously a possibility, although it's probably not viable. But just make L naught a value. And just keep in mind that L naught is a fixed value, okay? And that is the actual length. Now, what is c? C is the speed of light. That has an actual value as well. So L naught is a fixed value, and c, the speed of light, is a fixed value. The only thing that's changing is v. So L, the observed length, is a function of v, which is the speed of the ship. All right, well, hopefully that'll help. I do understand that all those letters is difficult for some students, and I don't blame you. All right, so here are the questions that are posed. First question is, what is the observed length of the ship if it is traveling 50% of the speed of light? What about traveling at 75% of the speed of light? And in fact, what is the observed length of the ship as the speed of the ship continues to increase up to c? So as the velocity of the ship gets closer and closer to the speed of light, what is happening to the observed length of the ship? That is a limit question. All right, let's go back to the first question. What is the observed length L of the ship if it is traveling at 50% of the speed of light? Well, traveling at 50% of the speed of light means that v is 50% of c, or v equals 0.5 times c. I prefer to write it as 1/2 c. Most students, though, I think seem to like to keep it as a decimal, so I'll keep it as a decimal for now. All right, so instead of v, I'm going to put in half of c because we're talking about velocity that's half of the speed of light. So I'm just going to make that substitution. And I have this expression here. And let's play around with the algebra, okay? So 0.5 times c. So square that. If you're going to square that, that means that the 0.5 gets squared and the c gets squared. So when I square that, I get 0.5 squared is 0.25, and c squared is c squared. Ooh, but look, isn't that nice? The c squares will cancel, leaving me with 1 minus 0.25. A real number, finally a real number, right? And 1 minus 0.25 is 0.75. Now, 0.75 is 3/4. And so square root of 0.75 is the square root of 3/4, which is the square root of 3 over 2. And notice that the L naught, the length of the ship, that just gets rewritten again and again and again. Except for rewriting it, you pretty much ignore it. All right, conclusion. Traveling at 50% of the speed of light, the observed length of the ship is L naught times radical 3 over 2. And now I'm going to switch it over to an estimated, oh, it says equals. It should be approximately equals. So the observed length is about 87% of the actual length. So that equals, that shouldn't be equals, that should be approximate. All right, what is the observed length of the ship if it is traveling at 75% of the speed of light? Really, we're just going to do the same thing we did before. 75% of c is 0.75 of c. And again, I'd prefer to write it as 3/4, but a lot of people don't like fractions, so I'll keep it as a decimal, but guess what? We're going to have to change it later. So whatever. It's like when do you want to take your poison, right? All right. So we'll leave it as 0.75 due to popular demand. And we're going to substitute 0.75c in for v. And then we're going to square 0.75c. So I square 0.75c and I get 0.5625. Don't round. No, 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 don't round. You'll be shooting yourself in the foot if you do. So 0.5625, and the c's will cancel as before, and I'm left with a nice little number underneath the radical. Do the subtraction, and you get 0.4375. So now you have to pay the piper. 0.4375, what is that as a reduced fraction? Well, I actually was thinking about it when I did it in terms of fractions. I had 1 minus 3/4 squared. 1 minus 3/4 squared is 1 minus 9 over 16. So 1 minus 9 over 16 is 7 over 16. So that's where I got the square root of 7 over 16, which is the square root of 7 over 4. Okay, so I still got it equals, don't I? Darn it. That should be as approximately. So traveling at 50% of the speed of light, the observed length L of the ship is about 87% of the actual length. That should be approximate, that wiggly line. There's the wiggly line. That's what it should look like. Traveling at 75%, the observed length of the ship is about 66%. So 50% gives us 87% of the actual length. Increase it up to 75% of the speed of light, and the length of the ship decreases. I'm sorry, the observed length, not the actual length. That stays the same. All right, so the observed length of the ship seems to be decreasing as the speed of the ship increases to the speed of light c. All right, so last piece. Let's go ahead and find this limit. This actually is easier than what we were doing before. Why? Well, as v approaches c from the left, v squared over c squared is just approaching c squared over c squared. No harm in that. C squared over c squared equals 1. This limit exists and does not cause us any problem under the radical because v is approaching c from the left, meaning v is less than c, meaning v squared over c squared is less than 1, and that keeps the radicand 1 minus v squared over c squared. That keeps that positive, which is what you want. It has to stay positive if you're going to take the limit there. So, and it does. So go ahead and take the limit. The limit as v approaches c from the left is, all we have to do is do that substitution, and I get 1 minus c squared over c squared. That's 1 minus 1 is 0, and then L naught times 0 is 0. And the observed length of the ship decreases down to 0 as the speed of the ship increases to the speed of light c. It was kind of fun. I hope you had fun. Let me know if you have any questions. Bye.